All right, so we're going to solve systems by graphing today. Now, a system is when we have more than one equation. In Algebra 1, we're going to focus on just having two equations. In Algebra 2, we'll show you how to do this with three equations, so you can have an idea of how this can be applied. So when we're graphing systems, I want you guys to graph first because this is going to give you kind of a visual of what we're solving for. So when we have a system, there's actually three different options for your solutions. So I'm going to draw three XY charts here, and let's talk about the options for our solutions. So we could have two completely normal lines, or what I would call normal, where these two lines intersect at a point, an XY point. This is when we have one solution. We can also have lines that are parallel. If they're parallel, are they ever going to touch? No. So this would be no solution. Or we might have a line here, and then we might end up with almost the exact same line, okay, which means we would have infinitely many solutions. Or if you want to shorthand it, IMS, infinitely many solutions, because they're the exact same line, which means those two lines are going to go on and on forever. They're going to have every single point is a solution for them. All right, so let's see what this looks like. Number one, I'm going to graph the first one in blue. So I'm going to do y-intercept and slope. My y-intercept is the b value, which is the 2. My slope is in front of the x, which is -1. So I'm going to go up 1, 2, put a point. From there, I'm going to go down 1 over 1, and I'm going to put a couple points on the graph because I don't know where these are going to intersect, and I want to make sure that I know exactly where they intersect so I have the correct point. Whoops. So there's my line. Now I'm going to do the second one in orange. So my y-intercept is at 1. My slope is a -1. So I'm going to go up 1 and put a point. From that point, I'm going to go down 1 over 1, down 1 over 1. Oh, wait. Hey, look. They have this different starting points, but the exact same slope. So which means they're parallel. If I have parallel lines, are they ever going to intersect? No. So this one would be no solution. Let's look at the next one. For this first one, what do we got? We have our y-intercept and our slope. Y-intercept is at 3. Our slope is at -5 over 4. So I'm going to graph that. I'm going to go up 1, 2, 3. From that point, I'm going to go down 1, 2, 3, 4, 5 over 1, 2, 3, 4. And I'm going to keep going. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3, 4, 5. Make my line. There we go. All right. Okay, I don't know why this mark is on here, but that should be a positive slope. Okay, so this next one. We have our y-intercept, and we have our slope. So my y-intercept is going to be our -4, it's the b value. My slope is going to be 1/2. Okay, so let's go ahead and graph that. We're going to go down 1, 2, 3, 4. Then I'm going to go up 1 over 2. Keep going until they hit. Up 1 over 2. Draw in our line. Okay, so I want you guys to pause the video. Tell me what point those two lines intersect at. All right, so we went over 1, 2, 3, 4. My x value is 4. My y value down 1, 2. So that would be our answer for -2. All right, let's look at number 3. Now, here's the deal with these. Yes, we could use our standard form and try to use cover-up method. However, just looking at this, looking at the first one, if I divide both sides by 5 on top, I'm going to have a decimal. And decimals are not fun to deal with when we're graphing systems. So let's solve for y. So I want you guys to go ahead and take this equation and go ahead and pause the video and get y by itself. Alright, so if I'm going to get y by itself, I'm going to subtract 5x from each side. Remember, we're just rearranging the equation. And then I'm going to divide everything by 2. That way I have it in y equals mx plus b form. So now I'm going to graph this guy. So from that equation, my starting point is at -4. And my slope is down 5 over 2. If I go down 5, I'm going to be off the graph. So I'm going to go up 5 and backwards 2. So 1, 2, 3, 4, 5, back 2. I think I have room for one more. 1, 2, 3, 4, 5, backwards 2. So there's my line. Not a very good line, but we're going to go with it. All right, now let's do the second one. Now this one you could use cover up because it comes out as whole numbers, but I would rather use slope because it just makes me more comfortable finding that point where they intersect. So I'm going to subtract x from both sides and then divide by -2. So we have y equals 1/2 x plus 2. So I'm going to go up 1, 2. Up 1 over 2. Well, if I keep going this way, I'm never going to hit that line. So I'm going to go the other way as well. Down 1, backwards 2. And there's our intersecting point. So now I'm going to put in my line. I want you guys to tell me what point those intersect at. Okay, so what do they intersect at? We have an xy point. My x value, I go backwards 1, 2, so -2. My y value, I go up 1. So there's where they intersect at -2, 1. Okay, let's try one more. All right, so that first equation looks a little crazy, right? I got fractions. I don't want to graph fractions. My starting point, a fraction, that's yucky. So let's solve for y and see what happens. But how would I get rid of fractions? We're going to multiply by the denominator. So I'm going to multiply both sides. They have the same denominator. I'm going to multiply both sides by 5. Remember, you have to multiply everything by 5. So this 1/5 cancels with the 5. We're left with y. Then we have to do 5 times -1, so -5x. And then 5 times this guy would be 5 times 4 is 20. 20 divided by 5 is 4. Now I have an equation that I can work with. I'm going to write it the other way just so it looks like something familiar. So there's my equation. From that equation, we're going to go down 1, 2, 3, 4, put a point. Then I'm going to go down 5 and over 1. Well, I can't go down 5. I go off the graph, so I'm going to go the other way. 1, 2, 3, 4, 5 over 1. Backwards 1. Remember, downhill's negative. 1, 2, 3, 4, 5. Backwards 1. So here's my slope. There's my line. Okay, now let's do the second one. I want you guys to take a minute and solve for y. All right, so to solve for y, what did we do? We add 4 to both sides. And then we're going to divide every single thing by -1. So I have -5x minus 4 equals y. I'm going to write that the other way. Okay, so let's graph it. Starting point, down 4, put a point. Slope is down 5 over 1. That goes off the graph, so I'm going to go up 5, backwards 1. Up 5, backwards 1. I'm going to make my line. And what do you notice? Go ahead and pause and tell me what the answer is. So these came out to be the exact same line, right? When they're the exact same line, they go on forever, we get infinitely many solutions.